All right, for our last lesson of the year, we're going to be looking at the last extra topic that Vincennes requires, which is hyperbolic functions. And these are trig functions that are based on a hyperbola as opposed to a circle. And I would recommend that you watch the first 4 minutes of a YouTube video that I've posted on Google Classroom that just gives you a visual of what a hyperbolic function is. And it just will, I think, give you a little bit better feel for what we're doing. Of course, you can just go along with the examples here and not really have a visual of it, but I would recommend looking at that video. So you read these as hyperbolic, for example, sine of x or hyperbolic cosine of x. And those two are the main two definitions. Hyperbolic sine is based on e to the x minus e to the negative x over 2. And hyperbolic cosine is based on e to the x plus e to the negative x over 2. And then all of your other definitions are what you would probably expect them to be, very similar to what you would have in circular trig. And then, of course, we can do derivatives and integrals of our hyperbolic trig functions. You might notice that we don't encounter negatives until we get down to cotangent, secant, and cosecant, the hyperbolics of those. So we'll look at our first two examples, and it says to find the derivative of hyperbolic secant of 5x squared. So y prime would equal, and so for this one, this is one of the negatives. So this would be negative, and it's hyperbolic secant, hyperbolic tangent. So we will keep the angle as we write this. And then, as you might imagine, we have to do the chain rule, and so we'll multiply by the derivative of the angle. And the only kind of simplifying would be to bring that negative 10x in front, and then just having the two hyperbolic trig functions following that. So this is your first example. And I probably will have to erase it to give myself enough room to do the second example. So actually, I'm going to try to fit it on there. For your second example, which is g of x equals the natural log of the hyperbolic cosine of x, g prime would equal, all right, for a logarithm, we'd have to do 1 over the argument. So 1 over the hyperbolic cosine of x, and then times the derivative of hyperbolic cosine, which is hyperbolic sine of x. And so g prime could equal hyperbolic sine over hyperbolic cosine. And that could simplify to hyperbolic tangent of x. So first two examples, and you'll just need to be sure that you reference the formulas that are on the what would be the front side of this sheet. All right, we will work on now doing the integration with hyperbolic functions. So our third example is where we're integrating hyperbolic sine of 1 minus 2x. And really, this is just a matter of using a u and then referencing your formulas. So the u in this case would need to be the angle. So u would equal 1 minus 2x, and then du would equal negative 2 dx. So as we try to work with this, we'll have the hyperbolic sine of 1 minus 2x. We'll need to multiply in a negative 2. So balance that with negative 1/2 outside of the integral, which means that we're integrating negative 1/2 integral of hyperbolic sine of u du. And if you'll reference your formulas, the antiderivative of hyperbolic sine is just positive hyperbolic cosine. So that'd be negative 1/2 hyperbolic cosine. And we could go ahead and substitute in the u, 1 minus 2x, and then remember plus c. So there's the first example. And then the second example, I chose one that would have a different type of u. So on this one, we are integrating the hyperbolic cosine squared of x minus 1 times hyperbolic sine of x minus 1 dx. So we might think that the u should be the x minus 1, but we're going to have trouble with that hyperbolic sine. So a better choice for you would be to choose that as the hyperbolic cosine of x minus 1. And then the derivative of that, so the derivative of hyperbolic cosine is positive hyperbolic sine of x minus 1. And the derivative of the x minus 1 is just a 1. And then we'll have dx. And I'm not sure that you can see the dx because of what I've got on my screen. So just trust me, that's a dx. All right, so we will be just integrating then u squared du. We don't have to make any adjustments whatsoever. And so we can use our power rule, u to the third over 3 plus c. And then finally, we'll want to substitute in. So your final answer would be hyperbolic cosine of x minus 1 to the third power over 3 plus c. Okay, I'm going to do one last example with you. And for this example, mostly I want to show you what happens when you have to evaluate a hyperbolic function. So this asks us to find the equation of the tangent line. So we'll do that by starting off finding the slope, which would be the derivative. So y prime will equal, all right, so the hyperbolic sine, the derivative of that would be hyperbolic cosine. We'll keep the angle 1 minus x squared and then multiply by the derivative of the angle, which is negative 2x. And then we need to know our slope at ordered pair 1, 0. So y prime would equal hyperbolic cosine of 1 minus 1 squared times negative 2 times 1. And so here we're going to have to do the hyperbolic cosine of 0. And so at this point, you might be thinking that there's a button on your calculator, but actually, you're going to need to use the definition of hyperbolic cosine that I gave you at the beginning. So hyperbolic cosine is e to the x. So our x in this problem is 0. So e to the 0 plus e to the negative x. So it's still e to the 0 in that case over 2. And then this is also multiplied by negative 2. So e to the 0 plus e to the 0, that would be 1 plus 1. So your numerator is 2 over 2 times negative 2. And so your slope is negative 2. And then after that, you're just doing y equals mx plus b to get the equation of the tangent line. So substituting in 0 for the y, negative 2 for your slope, 1 for the x. Then we would find that b equals 2. And the equation of your tangent line is y equals negative 2x plus 2. So my main point in doing this example is whenever, whether you're doing an integral or whether you're having to evaluate in a derivative, whenever you are evaluating a hyperbolic sine or cosine, you have to go back to the definition using e. So hyperbolic cosine, e to the x plus e to the negative x over 2. If it had been hyperbolic sine, it would be e to the x minus e to the negative x over 2. So just remember that anytime that you're having to evaluate. So good luck. This is your last homework. So homework 66 will be that last lesson that you'll do as an actual lesson. And let me know if you have any problems.